In this video, we're going to get some practice working with the central limit theorem for means. We'll look at a couple of examples on this page just so that we can see two different cases. The first says, suppose that we have a population which is left skewed with a mean of 220 and a standard deviation of 3.9. We will take a random sample of size n equals 75 from this population. Now, at first glance, this seems like a problem because we have something which is left skewed, and really the distribution we've talked about most up until this point is the normal distribution. We say, okay, if we had something which is unimodal and symmetric, right, our regular old bell-shaped curve, then I could answer this question. But if it's left skewed, then that means it doesn't look like our normal distribution, and we're going to run into a problem. But the central limit theorem for means says if we take a random sample of size large enough, and the cutoff that we use for that is n should be greater than or equal to 30 for these problems. If our sample size is greater than or equal to 30, then we don't really care about what the underlying population looks like. In this case, we just care that our sample size is large enough. So in this case, n is 75. That is certainly greater than or equal to 30. That means that we're good to go. So if we're going to approach this problem, we should probably find the mean of the sampling distribution and the standard deviation of the sampling distribution. So what's nice is the mean of the sampling distribution is the same as the population mean. So it's going to be the same as the population mean, which in this case is 220. So my mean in this case is 220. And the standard deviation, sometimes this is called the standard error. I am not really a fan of that terminology, but you may come across some resources online that uses that notation. I prefer the standard deviation of the sampling distribution. Is the same as the population standard deviation divided by the square root of our sample size n. So our population standard deviation is 3.9 divided by, in this case, the square root of 75. So if I divide this out, 3.9 divided by square root of 75, I end up with 0.4503. I'm going to be extra careful and just add on 4 decimal places here. So we've got our mean and our standard deviation, and I skipped over this. I didn't actually look at the question. It's kind of important. It says, what is the probability that our sample mean has a larger than 221? So we are looking at the probability of our sample. We want to know what is the probability that our sample mean is larger than 221. So if we were talking about the probability of our sample, that means that the central limit theorem for means kicks in. Anytime we're talking about the probability of a mean of a sample. So the first thing that you would want to do, first of all, is verify that the central limit theorem works by checking, hey, is n greater than or equal to 30? We've already said, yes, it is. The next thing, once you've established that, is to figure out what is the mean of the sampling distribution and what is the standard deviation of the sampling distribution. We've done that as well. So now I'm going to actually just go and draw this out. This should look very familiar to the other types of normal distribution problems that we've seen up until this point. We've just got a new mean and a new standard deviation. So our mean is 220. Let's put that right in the middle. We want to know what's the probability that our sample has a mean larger than 221. So 221, that's just going to sit somewhere on the right of our sample mean. And if it's larger than that value, then that means that we are going to be looking at this area right here to the right. That's the area that we want to find. So if we think back to these types of problems, we'd say, okay, well, we want to find, the z-score for this. My z-score is x minus the mean divided by the standard deviation. Really, the only thing that's going to change here is, well, we're talking about the mean of the sampling distribution and the standard deviation of the sampling distribution, which we've already found up here. So my x is my observation. That's the number that the question is asking about, which in this case is 221, minus my mean, which we said was 220, divided by the sampling error, or the standard deviation, which is 0.4503. And the thing to remember is we get to use normal distribution, which means we want a z-score. We really only need the first 2 decimal places. So 221 minus 220, and then divided by 0.4503, I ended up with a z-score of 2.22. And then at this point, we've seen these types of problems before. We would say, okay, let's go find the area to the right of z equals 2.22. So returning to my probability tables, we're looking for the positive z-score. Here is positive 2.2. I'm looking at this row right here. My second decimal place is a 2, so we're looking at this column, which means that the area to the left is 0.9868, but of course that's not what I asked you to find. I asked you to find the area to the right. So we're just going to have to do the complement really quickly. So to find this area right here, I want to take 1 minus 0.9868, subtracting that out, let's not make a silly mistake, is 0.0132. So once we get the mean and the standard deviation for the sampling distribution found, it should be a very familiar process, though, to what we've been looking at. Let's look at one more part of this before we move into another example in our next video. This one asks for number 2. It says, what is the probability that our sample has a mean less than 219.5? So again, we're talking about the probability of our sample related to our sample, which means the sample mean and the the mean of the sampling distribution and the standard deviation of the sampling distribution are all the same. So I'm going to just copy and paste those down here so that we have those in front of us. And let's just draw ourselves a little picture. We know the central limit theorem says, hey, we get to assume that this is normally distributed. My mean is 220. It sits right here in the middle. And if I look at my problem, it asks, what is the probability that our sample has a mean less than 219.5? So that is less than 220. So here's 219.5. We want to find the probability that it is less than that. So that means we are looking for the area to the left here. So we're going to be looking for this shaded area. So just like last time, we're going to find the z-score corresponding to this. Z is equal to x minus the mean of the sampling distribution divided by the standard deviation of the sampling distribution. So that would be 219.5 minus 220 divided by my standard deviation, 0.4503. So let me do that real quick. Minus 220 divided by 0.4503 gives me, in this case, I ended up with negative 1.11. So that's my z-score. In this case, I'm already looking for the area to the left, which means I don't need to subtract it from 1. Just the number that I see is the number that I want. So we're going to look for negative 1.11, in my table. So we're going to scroll over to the negative z-scores. So here, negative 1.1, we must be looking at this row right here. Second decimal place is a 1, so this is the column that we want. So the number that we're interested in is 0.1335. So our probability here, the probability that our sample mean is less than that value, is 0.1335. So hopefully once we get past those initial steps of determining that the central limit theorem will work for our problem, that our sample is large enough, and establishing what is the mean of the sampling distribution and what is the standard deviation of the sampling distribution, these should feel pretty familiar to the normal distribution problems that we did way back in Chapter 4.